Hey Bio, how you doing? Happy Monday. Hope your weekend was okay. Hope you're not too stressed out. Hope things are good and you're sleeping a lot like you're supposed to because you're an adolescent. Hey, by the way, speaking of that, I've noticed in the couple of Google Meets that I've done with brain teasers, which have been great, but I think I'm noticing that the ones that are earlier, maybe there aren't as many people awake yet, which is perfectly okay. So what I'm going to do is next week I'm going to adjust my office hours to at least a couple of days a week to be later. Okay, so hopefully you can get in there and we've had a good time with the two brain teasers we've done. They've gotten them when we've done a Google Meet. They've gotten them, eventually, and that's been great. So I just stop in, show your face. It's good to see you and know you're okay, and see each other's faces. So yeah, this is kind of the first real day of class. You'll get an actual assignment at the end of it, and that'll be due, by the following day that we're doing real work, which is Thursday. Okay, so let's get into it. All right. First, though, my son showed me this morning. I thought it was important enough that you should probably see it too. Did you know about this? I didn't know about this. Anyway, quick review. We talked on Friday about classification, and most importantly, we went through the eight taxa that we use in modern classification. The domain, which is a huge group of three different groups, but the one that we're in and everything else that you kind of think of as alive is eukarya. And then we go down to kingdom, phylum, class, order, family, genus, and species. Those last two, of course, used to make the scientific name of an organism, which we italicize if we're typing and underline if we are handwriting, and which you always capitalize the genus but not the species. Dumb way to remember that, one of many, is as follows. Dumb kids prefer cheese over fried green spinach. So that's that. Man, I hated to start with that. It's not the most interesting part of the chapter at all, but it really is kind of the way to start things off. So I apologize if that kind of puts you to sleep, but I promise it gets better. So you'll remember that we kind of looked at molecular differences and amino acid differences as a way to figure out descent with modification, as a way to figure out how related stuff is, right? We count the number of amino acid differences. In this case, it's hemoglobin. We used cytochrome C before, and we built kind of a tree of life doing that. We did it with cytochrome C. I talked about bears. And so what I want to look at now is part of modern classification, which, while Linnaeus started with just physical similarities, we now use evolutionary relationships as best we can determine them, and we're getting very good at determining them. But the way this started is kind of a cool little diagram that I want you to learn how to draw yourself, and that's what you'll learn today. It's called a cladogram, and what it does is it's a thing where you choose what are called derived characters, and derived characters are, you can think of them as milestones, like something that shows up and it's so good and so well adapted that it sticks around. It, when something like an ability to sense light showed up, it stuck around because it was awesome, and it allowed the little one-celled things that had it to either choose to be in or avoid the sun as they needed for their lives. And so that one, if we're doing a cladogram, we'd pick that as a derived character, and everybody that gets off the kind of evolutionary bus before that doesn't have it, and everybody after it does. We use these derived characters to separate new species from their ancestors, but more importantly, and what you're going to do with it is to track evolutionary history. So a group that shares a certain derived character, when they're all in the same boat, they all have the light sensing pigment, that's called a clade, all right, which is why we call this diagram a cladogram. It's a diagram showing evolutionary relationships, and it's based on those derived characters. And the whole kind of branch of evolutionary biology that deals with all this is called cladistics, also sometimes called molecular systematics. I'm sorry, evolutionary systematics. Anyway, cladistics is the term we're going to use. Basically, classify